So if you recall in the last video that we looked at, remember I was saying that you could answer that person when they ask you, is x minus 7 a factor of that polynomial? Your answer is yes, and the reason why you can say yes, that it is a factor, is because that remainder that you got there is 0. If you get a remainder of 0, that means that the divisor, in this case x minus 7, it is a factor. If you don't get a remainder of 0, it's not a factor. Let's look at the other side of this paper and let's do a couple practice problems. So now what they want us to do is look at all four of these different factors. Let's determine if which one of these binomials, if at all, are factors of that cubic polynomial there. So let's just do synthetic division to do it. So positive 4, we'd write down, not 4, but negative 4, a 1, a 3, a negative 10, and a negative 24. Synthetic division time. See what just happened there? See how we got a 0? So our answer, is this a factor? Our answer would be yes, because the remainder is a 0. Let's look at this next one. Negative 2. We're going to put the exact same numbers down. 3 plus negative 2 makes a 1. It's negative 2, negative 12. That would be 24. Add that up. Hey, guess what? X plus 2. You're also a factor. Let's look at the other guys. X minus 3. That means you put a positive 3 here, right? And then coefficients, 1. I'm just looking at those numbers at the top. It's too good to be true, right? Boy, we're getting a lot of factors here. Yes, this one is too. Interesting. Let's look at this guy. Negative 6. That would be what? Negative 3, right? That would make 18. And then this would be an 8. And then negative 6 times 8 would be 40, negative 48, right? And then when we add those up, I guess I could do the math on that if I was really interested, but you can see right now that's not going to be a factor, right? Because we know the remainder is not going to be a 0. Right? We get negative 72. So our answer here would be a no. You know what's really interesting about this? Which leads into the later units that we're doing here. See how the degree is 3? I think we could have completely factored this guy and completely factored it into those 3 factors. My claim right now that I'm saying here is I bet you that if you had some time and you took x plus 4, multiplied it by x plus 2, multiplied that by x minus 3, my contention, yes, my contention, is that you would get exactly this whole polynomial right there. If you're bored today, doing a homework or whatever, give that a look. I think that's what you should get. Maybe just to humor me, 4 times 2, that makes 8 times negative 3, negative, might be onto something there. Okay, let's continue. What else we got here? Remainder theorem. Interesting. I like the remainder theorem. One thing that can be kind of annoying about evaluating functions, especially really long functions like this right here, if I were to ask you, hey, what's p of 3? Back in the earlier units in algebra, you'd have to go ahead and go and do this. 3 to the 5th minus 2, and then 3 to the 3rd minus, and then 3 to the 2nd power plus 2. And then you have to evaluate all of that. Okay? The cool thing that you could use is something called synthetic substitution. Not synthetic division, but synthetic substitution. That if you divide a polynomial, p of x, by a degree higher than 1, by x minus a, then its remainder is actually what p of a actually is. So, take a look at what they did right here. Here's something that really trips students up. If somebody asked you, hey, here's a really long polynomial, and I want you to tell me what p of 3 is, do you see what makes this different and why Mr. Cook definitely said this is not synthetic division? Do you notice something that's different about synthetic division with that 3 right there and this 3 right here? It's the same number. Synthetic division would be us dividing by x minus 3, and see how that's a minus 3? Opposite game right there. Okay, get it, get it, get it. So then what you could do, as opposed to plugging in a 3 in there for all those x's doing the math, is doing synthetic division right there. Hey, wait, see that 0, see that 0? Do you understand why those zeros are there? Is there any x to the fourth? No, there is no x to the fourth. Keep going. See how there's 0 x's? So in their places, there you go. And so then they're doing their synthetic, they get the remainder right there. There's your answer. If I were to plug a 3 in there, you get 182. Now, I know what you're saying. I know what you're thinking. Why couldn't we just do this, Mr. Cook? Boom. Boom. 3, 182. So P of 3, 182. Why couldn't we just do that, Mr. Cook? Is that your question? My answer is, why not? Great way to check your work now, wouldn't it? Okay, so to get comfortable with that synthetic substitution, maybe type that into your graphing calculator, go to 3 on that table of yours, and just check. Not a bad idea at all. I love it. Keep doing it. It's awesome. You're great. Fantastic. Okay, take a look at this problem, using synthetic division to solve a problem. So if we have this polynomial which expresses the volume of that shadow box, what are the dimensions of the box? Okay, here's the only thing they tell us. The dimensions of that dimension right there, it's tough to spot right there. A lot of students miss it. There's an x plus 5 right there. So a lot of students are saying, how do they even do that? Well, that's what they're doing. They're taking that polynomial, dividing it by x plus 5, right? Synthetic division. And now take a look at the quotient they have right here. Boom. Remainder of 0. So that makes that this quadratic right there. See what they did there? And then with that quadratic, we have some tricks up our sleeves. Now, don't we? We could actually factor and find two numbers whose product is negative 48 and their sum is 2, which would be a negative 6 and a positive 8. So what we've been able to figure out is that whole cubic polynomial up there could have been factored into x plus 5 times x minus 6 times x plus 8. Well, where did the x plus 5 come from? Well, it came from this guy right there, right? Remember that was what started this whole thing? And then we're grabbing those other two, putting those right there. So those would be the dimensions of that box. Okay? Is there anything else floating around here? Oh wait, there's that synthetic substitution business right here. Okay? So great, you could use your graphing calculator here, or you can just grab that negative 4. Okay? A 1, careful, 5, 4, 3, 2, 2, 2, 2 is absent. So you put a 1, a negative 3 for the fourth power, negative 28, because 2 is absent, we put a 0 there, and then a 5, and then a 20. I probably would have this done if you just typed into the graphing calculator, I agree. So that'd be a negative 4, there's a negative 7, there's a 28, oh how nice, we get a 0 right there, multiply, get another 0. Yeah, sometimes that'll happen, this is nice. Another 0, a 5, multiply that, we get negative 20. Wait a second, this is weird. You mean to tell me that if we put a negative 4 in there, we're supposed to get 0? Something doesn't smell right about that. Let's use the graphing calculator and check our work. Alright, so that looks pretty good. Now, what we were trying to figure out was P of negative 4. So if I go to the table, remember I'm still at that 3 from the previous problem, so let's back it up to negative 4, negative 4, negative 4, negative 4. Huh! How about that? Just 0. So, great way to check our work. Boom. Can you start right here to answer that question if it was tested as multiple choice? For sure, you could. Why not? Okay? So there we go. There's synthetic division. There's lesson 5-4. Good luck.